Welcome to solverfy.
We are given a sequence and we are asked to find its generating function in part A. So we're told that the sequence AK is the number of solutions of x1 plus x2 plus x3 equals k, where x1, x2, and x3 are integers. So AK is number of solutions of x1 plus x2 plus x3 equals k, where x1, x2, and x3 have to satisfy x1 is greater than or equal to 2, x2 lies between 0 and 3, and x3 lies between 2 and 5. So, to find the generating function, first consider that the series representing x1 should contain only terms that power at least 2. So we have that the series representing x1 is going to be x squared plus x cubed plus x to the fourth, and so on. The series representing x2, this should only contain powers between 0 and 3, so this is going to be 1 plus x squared plus x cubed. And for x3, the generating function should contain only powers between 2 and 5. So this is x squared plus x cubed plus x to the fourth plus x to the fifth. And then the generating function is going to be the product of each series together. So this is going to be x squared plus x cubed plus x to the fourth plus and so on times 1 plus x squared plus x cubed times x squared plus x cubed plus x to the fourth plus x to the fifth. And this can be written as x squared times 1 plus x squared and so on times, you can rewrite this as 1 minus x to the fourth over 1 minus x, and this can be written as, factoring out the next squared, x squared times 1 plus x squared plus x cubed, and this is equal to, you can pull out an x to the fourth times, and this can be written as 1 over 1 minus x times 1 minus x to the fourth over 1 minus x times, and this can be written as 1 minus x to the fourth over 1 minus x. So that's one way to write it. Another way is if we re-expand some of these, we get x to the fourth times, and this is 1 plus x squared plus x cubed squared over 1 minus x. This is another way to write the generating function. And to find the term A6, we now consider this as x to the fourth over 1 minus x. We want to use the other form of the generating function. So this is going to be x to the fourth over 1 minus x times 1 minus x to the fourth over 1 minus x squared. This is equal to x to the fourth times 1 minus x so x to the fourth times 1 minus x to the fourth squared times 1 minus x to the negative third. And using the extended binomial theorem and series from the book, we have this is x to the fourth times sum from k equals 0 to infinity of 2 choose k times negative x to the fourth to the kth power multiplied by the sum from k. Instead of k, let's choose m equals 0 to infinity of 3 plus m minus 1 choose m times x to the m. And this can be written as x to the fourth times the sum from k equals 0 to infinity of 2 choose k, negative 1 to the k, x to the 4k, times the sum from m equals 0 to infinity of 2 plus m choose m, x to the m. Since we're looking for the coefficient of x to the sixth, we want this to satisfy 4 plus 4k plus m equals 6, which means that 4k plus m has to equal 2. However, this is only going to be possible if k is going to be 0 and m is equal to 2. And so in this case, we have that a 6 is going to be equal to, if k is 0, we have 2 choose 0 times negative 1 to the 0 is just 1 times, and then 4 choose 2. And this is equal to 2 choose 0 is simply 1, and 4 choose 2 is 4 times 3 over 2, which is 2 times 3, which is 6. And so our answer is 6.